Hello and welcome to another math formula deriving video. In today's video, what we are going to learn is the formula that is used to solve quadratic equations. So quadratic equation is an equation that looks like the form ax squared plus bx plus c is equal to 0, where a, b and c are constant terms. So we have seen that this formula, the equation ax squared plus bx plus c can be solved. The values for x can be solved using the formula x is equal to minus b plus or minus square root of b squared minus 4ac whole thing divided by 2a. We refer to this as the quadratic formula. Right? So what we are going to learn today is how do we get this formula and what are the steps involved in deriving this formula. So before we get started, we have to learn a technique that is referred to as the completing square, because we are going to use that technique in order to derive this formula. So we call this technique completing square. So let's see what this completing square is. Completing square is a technique that is used to write a quadratic equation using a perfect square term, to involve a perfect square term, to include a perfect square term, right? So let's see how we can do that. We're going to take an example to see how to do completing square. So let me get an equation x squared minus 6x minus 3 is equal to 0. So we have a quadratic equation. Now we are going to do what is known as the completing square. So when we do the completing square, the first thing that we have to do is to make sure that the coefficient of the x squared, which is here, is 1. So luckily in this case it is actually 1, but if it was not 1, we would have to make it 1 by dividing by whatever the number is here. So what I mean is, if there was 2x squared here, we would have to divide the whole equation by 2 to make sure that the coefficient of x squared is 1. Right? So in this case, luckily it is 1, so we don't have to do any division. We can directly go to the next step. So if the coefficient of x squared is 1 in completing square, what we do next is we take x out of the x squared term, then we take half out of the second term. That means we divide the second term by 2. So we have minus 6 divided by 2, which is minus 3. So we take minus 3 from there, and then we square this term. Right, so that is the step involved. Take x from the first x squared and take half of the second term. So we have took half of the second term and we squared it. So after we square it, we can now include the third term, which is already there. We're not going to make any changes. We will include that here, minus 3. Now we have to do one more step, which is to include the square of the term here. We need to include the square of the term. So that means minus 3. We will square it. We get 9. So we need to subtract that 9 from the expression. Minus 9 is equal to 0. Right, so these are the steps involved in completing the square. First, make sure that the coefficient is 1, and then take half of the second term, half of this, then we square that term, then we include the already existing term, and then we square the minus 3 here, which is half of the second term. We square it and subtract that. Right, so those are the steps involved in completing the square. Let me continue with the equation. So we have x minus 3 whole thing squared. So this is minus 12 is equal to 0. X minus 3 whole thing squared is equal to 12. Now in order to remove the square, we can take the square root of the other side. So x minus 3 is equal to plus or minus square root of 12. Then we can move the 3 to the other side. So x is equal to 3 plus or minus square root of 12. So we have now been able to get an answer for the value of x using the quadratic, using the completing square method, right? So this is the same technique that we are going to use to derive the formula for solving the quadratic equation. So here we can see these are the steps involved. Make sure that the coefficient of x squared is 1. Coefficient of x squared is 1. Then take half of the next term, minus 3. Then include the existing third term, minus 3 again. Then square half of the second term, which is 9, and minus that from the answer, right, equal to 0. So those are the steps involved in completing square. We will now try to derive the formula for the quadratic equation using this method. So we are going to start with the general form of the quadratic equation. Ax squared plus bx plus c is equal to 0. Again we are attempting to do the completing square for this equation now. So here we can see that the coefficient of x squared is not actually 1. So ax squared plus bx plus c equal to 0. The coefficient of x squared in this case is a. So we have to get rid of the a. What we will do is we will divide this equation, the whole equation, by a. We will divide by a. So we get ax squared divided by a plus bx divided by a plus c divided by a is equal to 0 divided by a. So here we can see that a and a gets cancelled out. We are left with x squared plus b over ax plus c over a, which is equal to 0. So we have done the first step, that is to make sure that the coefficient of x squared is 1. Now we will proceed with the second step, that involves taking x from the first term and taking half of the second term, b over a. When you take half, that is b over a multiplied by half, we will be getting b over 2a. So we will include that as well. In this case it's plus b over 2a. We will square this, include the already existing term, plus c over a. Then subtract the square of the second term. So we're going to square this. B over 2a squared would give you b squared over 4a squared. So minus this. Which is going to be equal to 0. So that is the completing square. We will now move the constant terms to the other side of the equation. So you can have x plus b over 2a whole thing squared. I'm going to move the constant terms to the other side. B squared over 4a squared minus c over a. We move these to the other side. We can now take the square root to get rid of the square. So plus or minus. Remember, square root has a plus answer as well as a minus answer. 4a squared minus c over a. We can now try to make the denominator of the right hand side a common denominator. We can see that 4a squared is one of the denominators and a is the other denominator. So the common denominator would be 4a squared. So to achieve that, we can multiply this term by 4a. So square root of b squared over 4a squared. C times 4a is 4ac, and a times 4a is 4a squared. Now the denominator is common, which means we can simplify the numerators. B squared minus 4ac over 4a squared. Here we can see that the term in the denominator, 4a squared, is a perfect square. 4 is a perfect square, and a squared is also a perfect square. So we can take the square root of the denominator and leave the square root only in the numerator. So plus or minus, we are going to leave the square root in the numerator and take the square of the denominator, which is 2a. Square root of 4a squared is equal to 2a. Next, what we can do is we can move the other constant term b over 2a to the right hand side as well. It goes there as a minus b over 2a. So plus or minus square root of b squared minus 4ac divided by 2a. Again, we can see that the denominators are common now, 2a and 2a, which means we can combine the numerators, minus b plus or minus square root of b squared minus 4ac divided by 2a. Right, so that is what we were after. We have been able to derive the equation or the formula that is used to solve quadratic equations. Here we can see that the values of b, the values of a, and the values of c can be substituted into this formula to get the solutions for the quadratic equation that we are after, right? So yeah, that is how we derive the formula for quadratic equations. See you guys in another video.